I want to talk about the calibration procedures used for the iETEK. There are two calibration procedures. One is a TOF calibration or time of flight calibration, and this is required each time the program is restarted. The second calibration is a thickness calibration that uses two of the metal calibration blocks, and we recommend that this really only needs to be done once a year. Before I start talking about the calibration procedure, let me run down again, as I've done in some of the earlier videos, the basic components of the system. The gray enclosure contains the A to D conversion instrumentation, the ultrasonic pulsar and the receiver, the stepper motor drive and control, and the load cell signal conditioner. Other components, external components of the system, are the stepper motor shown here, which is connected to a long lead screw, which goes down to a sensor platform. And the sensor platform contains the two sensors, the lower sensor and the upper sensor. And then we're now pointing at the user interface. Okay, so the next thing we'll look at is the graphical interface. This shows the calibration interface. To do a calibration, you simply press the time of flight calibration. You get a message that tells you to make sure you've inserted the calibration block. The system then scans to find a signal. It measures the transit time of that signal, compares it with a known calibration transit time, and that's essentially the time of flight calibration. You can do multiple calibrations if you want. We've also shown here the distance calibration. Different button, you calibrate the device. It now asks you to put in a distance calibration block. You put that block in and it'll remeasure that particular block. The raw data display shows things scanning. It measures that distance and then calibrates it with the known distances, gives you a pass-fail message. The one thing about the distance calibration, you are required that after you do the distance calibration, you have to go back to the large 1-inch thick gauge block and remeasure that to reset the system. Once you've done that, then you're effectively, everything is completed. Now, the other thing to look at is to look at what you're actually doing when you're doing this GUI manipulation. This shows Loretta pulling out the 1-inch diameter gauge block. You insert that between the two transducers. You then press the gauge block calibration, the TOF calibration symbol. The platform moves down, measures the time of flight, compares it with a known time of flight, and generates an offset number. Now, to do the distance calibration, then what you need to do is choose the thinner distance calibration block, set that between the two transducers, initiate the distance calibration measurement. The platform will come down and measure the distance between the two transducers. Once it does that, it will compare essentially the two distances and generate, generally, if it's within tolerance, a pass-fail indication. And as I mentioned before, you will have to, after you've done the thin calibration, you will have to go back and as the final step, go to the 1-inch calibration block and do a remeasurement. I think the menu has words on it that tells you exactly what the procedure is for doing all of the manipulations of the sample. Once that's done, the new calibration